Okay, this week's topic, percent yield. As always, please copy this into your notebook. Use the space bar to start and stop as needed. Okay, now what you're going to find is that percent yield calculations are simply applying what you already know, writing a balanced chemical equation and a stoichiometric mass calculation. Okay, now before we can get going on a percent yield problem, we need a couple of definitions. First, theoretical yield, the maximum amount of product that can be produced from a given reactant. And in fact, all of the mass calculations that you did last week, stoichiometric calculations, were theoretical yield calculations. You were given a certain amount of a reactant and you were asked how much theoretically you should be able to make of a product. We call that the theoretical yield. It's kind of in a perfect world, the amount that you would be able to make. So it's determined from a mass stoichiometric calculation. Okay, now, in the real world, we don't make the theoretical yield. Often we'll have a little bit less depending upon the problems that may have arisen in the reaction. Now, possibly the reaction didn't take place entirely. There was something left over. Or there was some sort of problem that caused the reaction not to go to completion. We call the amount that's actually made the actual yield, the amount of a product produced in an experiment. So kind of like think if you're making cupcakes and you have a packaged mix that you're using and it says you should be able to make 24 cupcakes, but when you actually make it, you end up making 22 cupcakes. You know, something went a little wrong or you added a little too much of this or that. Okay, so that's the actual yield. The box tells you theoretically you should be able to make 24, but you only made 22. That's your actual yield. The comparison between those two is what we mean by percent yield. Percent yield is just a calculation. We take the actual yield, the amount that we actually made from the experiment, and divide it by the theoretical yield that we calculated. And then, of course, we multiply by 100 to give us a percent. Okay, now, in class, we do an actual yield calculation lab, which is unfortunate. You're not going to have an opportunity to do that. Okay, so let's do an example problem. In an experiment, 25 grams of ammonia decomposed to form 17.5 grams of nitrogen gas. What was the percent yield? Okay, now you'll always be given the actual yield in the problem itself. And in this case, it's the 17.5 grams of nitrogen gas. Always given, not calculated. So in the problem itself. If you were to do a lab, like a lab that you never got to, you would have calculated the amount of a product that you would have made and then actually measured the mass that you made. And it likely would have been a little bit less than you had calculated, the actual yield, less than the theoretical yield. All right, now, of course, anytime you make a relationship between one substance and another substance, in this case ammonia, 25 grams of ammonia, 2 grams of nitrogen gas, we need a balanced chemical equation. Okay, please never try to make a relationship between one substance and another substance without a balanced chemical equation. It's the only thing that we can use to relate substances. To balance this equation, okay, now, like a stoichiometric calculation, let's summarize what we're given. We're told that we have 25 grams of ammonia, and we want to figure out what is the theoretical yield of nitrogen that we should be able to make. So again, that's a stoichiometric mass calculation. So we're going to calculate the theoretical yield and divide that into the actual yield. So 25 grams of ammonia, converting to moles of ammonia, converting to moles of nitrogen, converting to grams of nitrogen, gives us 20.6 grams of nitrogen. Okay, now percent yield, that is the theoretical yield. Percent yield is the actual yield divided by the theoretical yield. So we now have everything that we need. In the problem itself, it gives us the actual yield. We just calculated the theoretical yield, and that will give us 85.0%. And it's just that simple. In the problem, it'll give you the actual yield. You need a balanced equation to calculate the theoretical yield. Dividing the theoretical yield into the actual yield multiplied by 100 gives us the percent yield. Okay, now the next problem I'm going to show you, you might want to pause it after I give you the problem and see if you can do it, and then I'll walk you through it. Okay, in an experiment, 75.0 grams of potassium reacted with excess water to form hydrogen gas and potassium hydroxide. At the completion of the reaction, 1.67 grams of hydrogen was produced. Calculate the theoretical yield and the percent yield for this single replacement reaction. So first, let me give you a couple of things before you might try it yourself. Okay, now, the 1.67 is your actual yield. Remember, that's always going to be given to you in the problem. And then, of course, you need a balanced chemical equation. Now, this reaction is what I did on the very first day of class. Remember when I dropped potassium into water and it burst into flames? It was the hydrogen gas that burned, and to balance that equation, we need that. Okay, so why don't you pause the video, see if you can do the calculation. You want to calculate the theoretical yield and then the percent yield. Okay, so let's see how you did. We start with 75 grams of potassium, and we need to figure out the theoretical yield of hydrogen gas. So always start with what you're given, converting the potassium into grams of potassium into moles, converting it into moles of hydrogen, converting it into grams of hydrogen. So our theoretical yield is 1.94 grams. And then to calculate the percent yield, just take the actual yield that's given in the problem, divide it by the theoretical yield, which gives us 86.1%. All right, let's do another problem. And again, you can pause the video and see if you can try it yourself, or do it yourself. In an experiment, 32 grams of propane is burned. At the completion of this combustion reaction, 87.8 grams of carbon dioxide was collected. Calculate the theoretical yield and percent yield. All right, so I'll let you do everything yourself here. Pause the video, see if you can determine the percent yield, and then start it up again. Okay, first, clarify the actual yield, the 87.8 grams of carbon dioxide. Our balanced equation, it's a combustion reaction, so remember you have to have oxygen in that reaction. Okay, so to balance the carbons, balance the hydrogens, and then to balance the oxygens. We start with 32 grams of the propane, and we're interested in the carbon dioxide, the theoretical yield. So converting the grams of propane to moles, into moles of carbon dioxide, to grams of carbon dioxide, our theoretical yield is 95.8 grams. Dividing that into the actual yield gives us 91.6 grams. Okay, one more. In an experiment, 10 grams of magnesium reacted with excess hydrochloric acid, forming magnesium chloride. At the completion of the reaction, 29.5 grams of magnesium chloride was produced. Calculate the theoretical and percent yield. Again, I encourage you to stop the video, see if you can do it yourself, and then start it up again. Okay. The actual yield, our balanced equation, starting with 10 grams of magnesium. The magnesium chloride will be what we need to calculate, the theoretical yield. Theoretical yield, 39.2 grams. Dividing that into the actual yield given in the problem gives us 75.3%. Okay, that is it. You have 4 problems like this on your homework. I will see you at the Google Meet. That's it.